Alright, in this tutorial I want to just talk about a couple new items we've added regarding the flooded belt case and the structural loading case. So I went ahead and opened up a example file that I just made up here, and essentially it's just got a conveyor running some iron ore at 3,000 tons per hour. So as always, you can always right click on the material profile and look at this flooded belt condition. So what essentially Sidewinder's done for us, and just like I said, this is current and existing, is by right clicking flooded belt I can see this is 5661 tons per hour, even though my design case is 3,000. So basically just filled up the conveyor and said how much load can we fit on the conveyor. Now what we've added is essentially under the project information, down here we've added the structural loads tab. So structural load slash flooded belt, I guess, input tab. And for the flooded belt, you can now specify that the material density, surcharge angle, and the frictional condition for the flooded belt case. Previously, the flooded belt case always worked off of material type 1, and there wasn't really any way of changing that. You obviously could have created another custom case and used material set 2 and played around with it to get the flooded belt condition for different density. But now you can just go ahead and enter it right there. If you want a different surcharge angle or whatever, you can just go ahead and enter it. When I run the calcs and look at that flooded case, you can see now it's used the higher density 2200 kilogram per meter cubed instead of the 1900. It's used the 15 instead of the 20-degree surcharge angle, so on and so forth. Also shown on the flooded belt information here is just the weight of the material plus the weight of the belt for the flooded condition. That's a nice number for the structural stringer guys to have, as well as just what the motor power is and the belt safety factor is. Running motor power for that case and the belt safety factor. And that's why we've added the frictional condition. For some users and some conveyors, you might want just normal friction. Other times you might want to say, alright, nope, I want it for the high friction. This is my absolute, obviously, worst case scenario for the flooded belt condition. So that's pretty much it for that. Regarding the structural loads, how structural loads had worked in the past is essentially Sidewinder took the conveyor and just kept increasing the conveyor tonnage until it reached 100% nameplate power. And then at that nameplate power, it performed the starting and stopping dynamics, looked at all those cases, grabbed the maximum tensions, belt tensions, and then multiplied those by 10%. And now there was nothing wrong with that. We've essentially just added, we've got a lot of comments back from users that say, oh, you know, we use plus 5% or plus 15%, or we use running plus 50%, or you know, we use starting 200% torque or whatever. So we've essentially just allowed Sidewinder to let you, the user, to enter whatever you want. By default, Sidewinder will default to, actually this is 1.1 for the structural multiplier is the default value, but this is what Sidewinder defaults to. Let me just go ahead and delete that. The tonnage, you can enter a tonnage for the structural load case, or you can leave it blank. Again, if I leave this tonnage blank and run my calculations, it will essentially calculate the tonnage required to meet 100% nameplate. So on this conveyor we can see, well, the flooded belt was only 68% nameplate. So actually I had to increase the structure, or the tonnage to almost 9,000 tons per hour to meet this 100% demand power. Now that's not always the case. In some cases, I mean, depending on how much reserve power you have, what size motors you've installed, or how much overcapacity you have, this could very well be less than your flooded belt tonnage. So it's kind of nice to be able to just actually click on this page and look and say, okay, flooded is 5661, the structural's 9,000. Okay, well maybe I limit it to 5661, and I could go ahead and go in here and just say, alright, I want 5661, and that's what I'm going to use for my structural case. Alright, nothing wrong with that at all. Again, I'm just by default, however, it loads the conveyor up to 100%, and that's kind of nice because what happens if, say, we're loaded in this flooded case, or even if the belt's empty for that matter, and we block the loading point gets blocked, and so essentially your tensions just keep increasing to that motor torque. And we can now model that, simulate that case. We can go in here on the tonnage and I can actually pick blocked chute. So what this will do, if I selected this option, okay, and run the calculations, it will use my default tonnage, or had I specified a tonnage, say 5661 or whatever, it will use that default tonnage and perform the calculations on that tonnage, but also add a blocked chute drag value at the first loading point until the conveyor reaches 100% nameplate power. Now you might look at this and say, well, what's the difference in either case? Whether I overload the belt or I have this plug chute, I'm still going up to 100% nameplate rating. And you're absolutely right. I mean, it's sort of a user choice. Of course, depending on the conveyor geometry, you could get different tensions along the conveyor, because in one case you're increasing all the tensions right at the tail, versus in the other case you're adding this fictitious load on top of the conveyor to reach the maximum power. So 9 times out of 10 you probably get very, very close to structural tensions, to the same structural tensions, but it's really up to you, the end user. Some other inputs we've added, obviously the frictional condition. Again, you could come back and say, well, there's not really any point if we leave this blank, for example, and the tonnage blank. Well, in this case, it's going to pick the tonnage, again, required to give us 100% nameplate power. Well, if I go to normal friction, instead of this 8996, I'm only going to get, or I'm going to get more, 9,000, because we're under normal frictional case, but I still achieve that same 100% nameplate power. So this is sort of irrelevant if you're working off this 100% case. But if you want to work off the flooded belt case, well, then it's very relevant. You can say, all right, I want the flooded belt, high friction. Look, that's what's going to be my max structural case. I'm not going to worry about the chute getting plugged, or the chute's been designed in such a way or whatever that there's no way it's going to get plugged, and by pushing that to 100% is over conservative, and people feel that way, but it's again up to you guys as the end user. So you certainly can pick and choose however you want it. The starting torque, previously the structural tensions for starting were always done with whatever your input torque was. But we have users that say, well, for our structural case, in this case we've got a VFD or whatever, maybe you got a fluid coupling, and they say, well, even though the fluid coupling only does 150, maybe it's overfilled or whatever, and in that case we want to use 175 or 220 or whatever the number may be. You can now go ahead and just enter that right there, and boom, it automatically does the calcs now at that 175. And it also gives you the safety factor for that starting condition. Now you can always go back and double check this exactly, and I just want to show you this here. There's no difference if I'm going to come over here and say fully, actually I'm just going to call this structural case, and we're going to make a high friction case. Actually, I'm going to go back and just delete a couple of these things to show you how this works exactly. So we'll just go back and make our structural case, call it high friction. I run the calcs and I can see, all right, that took 8996 tons per hour to give me 100% nameplate rating. So I'm going to put my 8996 in here and run my calculations. And so now I get 100% power. If I go over to my case tab, I should have exactly 100% power. Oh, wait, I don't. I have 106. Why is it 106? That's because the structural case, and again I talk about this in the manual and also in the report, which I'll show you in a second, that this case assumes that your motor and reducer losses are also 0. because we want a structural case. We want the maximum belt tensions when that motor, is overloaded or accelerating or whatever. So we're going to put all our gearbox and reducer and motor slip all to 0. So if I go ahead and specify those to 0, and actually in this case we're using the high frictional condition, so I have to put the mechanical efficiency here as well at 0, and run the calcs. Now when I look and see this additional case that I created, hey, how about that? Exactly 100%, exactly matches that with this 8996. So the point that I'm trying to make here is that these 2 extra cases, Sidewinder actually makes 2 hidden cases. I mean, it actually, if you can imagine here, even though we only show 3 cases, it actually runs 5 cases, and it just uses these last 2 cases just for this output page, and then essentially throws it away. Now coming back here, so we've got our structural case. If I look at my tension multiplier, so if I go over here and I say, oh, I've got 338 800 is my maximum structural tension. Well, that should match my fully loaded max tension. Well, it happens to be 308. Well, 308.1 times our structural multiplier of 1.1 gives us exactly 338 800. In fact, if I just go back here and make this a value of 1 just to show you that and run, here we go. Now we've got 308 075. 308, whoops, sorry. 308 075, 308.1. Okay, so you get exactly the same values as the point here. And you can always go back and double check that. Starting torque, again, if I wanted to say 200% starting torque here and I run that, now I can see, ooh, now my peak tensions are 466. I can verify that going into my case tab here and saying, give me, instead of 125, give me 200%. And this is something that's very nice now in the structural case, because this is giving 200% for all these cases. Well, 466.4, just to verify that, 466.4, exact same number. But I can now just do that just for this structural case, which is quite nice. So that's what that is, the structural multiplier. The next one is include structural dynamics. So by default, if that's set to yes, Sidewinder looks at all the load cases, full, empty, incline, decline, high friction, any load cases you have, plus the structural cases, all the starting and stopping, and picks the maximum values. If you set this to no, it will still use all the dynamics for all your other load cases, full, empty, inclines, running and starting and stopping, but for the structural case, it will only use the running case condition. And that's for people who have said, nah, what we want to use is 100% nameplate plus 50%. Fine. And just say no here and make that 1.5. So now we've basically used the structural running condition, 100% nameplate power, plus 50%. Simple as that. So that's the flexibility. That's what's quite nice about this. Again, whether you are going to set that 100% based off of just increasing the tonnage or blocking the chute at the tail. So I think that about wraps it up. Reports. If we go into our report and you click this structural loading tab, that's always been there. We just added a few new items to the report here. If I go down to structural loads, you can see it specifically says exactly what was case was included, 9,000 tons per hour. This case results in 100% nameplates. The maximum tensions have been multiplied by 150%, so on and so forth. Gives you a structural table, gives you also this flooded belt information, and we've included a flooded belt plot as well.